Hey everybody, this is Abhay, and in this video we are going to solve a problem called minimum path sum. In this question we will be given a 2D matrix. This is our matrix or 2D array, or you can see here is our matrix, and we have to return the minimum path sum from top left, that is here 1, to right bottom, that is here, which is also 1. We have to return the minimum path sum. Path sum is basically we will add up all the element that we step on traveling from this side, that is left top, to bottom right. So here in this case the minimum path sum is 1 3 1 1 1, which is 7. So 7 is the minimum path sum required to get from left top to bottom right. So now let's see how we are going to solve this problem. So here is our 2D matrix. We have 1 3 1 1 5 1 4 2 1, and we have to start from the top left corner, that is here 1, and reach to the bottom right corner, that is here, and return the minimum path sum that we got. So a path sum is basically we will sum all those elements that we step on. For example, 1 3 1, again 1 and 1 is the minimum sum to reach to point this, that is 1 3 4 4 1 5 5 1 6 6 1 7. So 7 is our answer, which is the minimum path sum to reach this bottom right corner, right? So this is basically a dynamic programming question. So how we know? It says that we have to find the minimum path sum, or we have to minimize something, or we can say we have to optimize the solution. So that's a clear indication of dynamic programming. So in dynamic programming, what we do, we find, so we have a big problem, and then we break that big problems into smaller problems, and we find the solution of that smaller problems, and that solution will eventually give us the solution of the bigger problem. So what we are going to do, we will create another 2D matrix of same dimension, that is 3 cross 3 in this case, and we will store the path sum of to reach that point in this index. For example, here is 1. To reach this one from the top left corner is this only element, so we will write 1 just itself, and then we are at 3. So we have to reach 3 from the top left corner, that is only one path is possible, that is from here to here. So 1 plus 3 4, so this is 4, right? So and now pointer is here, this one we have to find the minimum path sum to reach this point. So we know in dynamic programming we have a solution to the smaller problems, and we use that solution to find the bigger problem. So we are at this point here, and we know this is the minimum path sum to reach at this point is 4, and the only possible path is this, right, from the left side of 1. So we will add 1 to this 4, so it is 5. Simple. Okay, so pointer is, let's say, here, and the only possible path to reach here is this. So 1 plus 1 is 2 in this case. Now 5 is here. We have two possible ways to reach 5, either 1 3 and then 5, or 1 1 and then 5. So as you can see, to reach here the minimum path sum is 2, and to reach here the minimum path sum is 4. So simply this is the minimum path sum possible, 1 1 and 5. So 7 here. So pointer is here at 1, this is at 1, and as we can see, we can either go from top or from left. So for example, we have to fill this position. So top is 5 and left is 7, and we have to find minimum. So we will come from top, that is 5, and plus 1 6. So 6 here, right? Now 4 here, 4. So this is position that we have to fill, and only possibility is that we'll come from above. So it will 1 plus 2 3, 3 plus 4 7, so 7 here. Okay, not 7, it is this is 4 and we'll add just 2, which is 6, because 6 2 is itself the sum of path sum to reach at this point. Now pointer is here 2, so we have to fill this position. So left side sum is 6 and top is 7, so we can either come from top or from left. So left side is 6 plus 2 is 8, or 7 plus 2 is 9, so minimum is 8, so we will write 6 plus 2, which is 8. Okay, 8 here, and then 1 here. So top is 6 and left is 8, so 6 plus 1 is 7 and 8 plus 1 is 9, so minimum is 7, so 7 here. And this is the value that we have to return, because we have to return the minimum path sum of right bottom index, right? So that's it. This was our logic. We will create another 2D matrix and we will store the path sum of corresponding matrix that we have in our question, and we will write the minimum path sum of that point, and we will eventually return this position, right? This 7. So now let's actually solve this problem. Okay, so here it is. Now we will check for the base case, that is if grid doesn't exist, that is grid is null, or grid dot length is 0. In this case we will simply return 0 because there is no point going further. And now we will create our dynamic programming. We will create a 2D array. That is what we do in dynamic programming. So int, we call it dp is new int, and size will be grid.length, grid.length, and here it will be grid 0.length, right? This is the length of row and this is the length of column. So here is our array. In this array we'll simply store the minimum path sum at that particular index or position. So we will now start traversing for int I 0 I less than grid dot length I plus plus, and again we have j, this is for column, int j 0 j less than grid 0 dot length and j plus plus. Now we will start adding the path or the element that we step on. So dp I j will add grid I and j, right? Now if I is greater than 0, I is greater than 0 and j is greater than 0 as well, so in this case we can either come from above of us or from the left side of us. For example, if we are at 3, if we are at 5 here, we can either come from top of us, that is here, or left of us, that is here. So we will take the minimum of both of them, so either top or left, the minimum of that. So dp I and j will add, that is math dot minimum, and minimum of either left side dpi minus 1 j, or dpi j minus 1. We will take the minimum of both. Or else if I is greater than 0, since I is greater than 0 and j is 0, so the only possibility is that we can come from left of us, right? So dp I j will be dp I minus 1, and this is a j, that's it. Okay, else we have one more condition. Else if j is greater than 0, j is greater than 0, in this case we come from the left of us. dp I j is dp of I and j minus 1, right? And what we have to return is simply the position, is simply the element at right bottom corner, because that store the minimum path needed to travel at that point. So we will simply return that position, which is dp dot length minus 1, or dp dot, okay, length minus 1. This is dp 0, 0 length minus 1, right? Okay, no, so now let's submit this one. Okay, we got an error and that says cannot find the symbol length. This is length. Submit. So as you can see, our solution is accepted. So that's it for this video. If you enjoyed the video, hit the like button and hit dislike if you didn't, and subscribe to the channel for more coordinated problems. See you in the next video.